Hi everyone. In this video, we're going to discuss Chapter 6A, which is about how you characterize data. One of the things we're going to be looking at is measuring central tendency, which is another way of saying calculating mean, median, and mode. And we're also going to look at some more information from graphs. So measuring the center in a distribution, there's a couple different ways we do it. One of them is to find the mean. Usually when people think of average, that's what they think of. They think of the mean. To calculate it, you add up all the values that you have and you divide by the total number of values in the list. The median is another way of calculating an average, however. It's not what we typically think of when that word is used, but median also will tell you the middle of data. And specifically, the median is the exact middle once data has been sorted from least to greatest. So you need to put your items in order first, then you figure out where the middle is. If the number of data items that you have is an odd amount, then the median will be right in the middle. It'll be one number and it's easy to find. If you have an even amount of data, there'll be two numbers that are in the middle. And in that case, you would find the mean of those two. So you would add the two up in the middle and divide by 2. And that would give you your median. And then the last one is the mode. The mode is the number that comes up the most common value. You might have more than one mode, or you might have no mode. If more than one thing comes up the most, then all of them are modes. And if everything comes up at just exactly one time, then you will have no mode. So here's the first example. 8 grocery stores sell the PR energy bar for the following prices. They want the mean, the median, and the mode for these prices. So first, let's start with the mean. So I'm going to add them all up and divide by 8 because there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And I got $1.41. For the median, I am going to sort them, make sure that they're in order from least to greatest, which they are. And then I need to find the one in the middle. Now, since there is 8 of them, that's even. 2 of them are in the middle, the $1.35 and the $1.39. So in this case, I'm going to add these up and divide by 2 because there's 2 of them. So $1.35 plus $1.39 and then divide that by 2 gives me a median of $1.37. If you think about it, 137 would be right in the middle of these two numbers right here. And then the mode is the one that comes up the most. And in this case, that would be the $1.29. That one comes up twice. Everything else is coming up just once. All of these things together now are called measures of central tendency. They all will tell you something in the middle of your data. An outlier is a data value that doesn't seem to fit with all of the rest of the data. It'll either be much, much higher or much, much lower than all of your other values. And because of that, it'll pull the mean either up or down. So if you look at the following set of exam scores that I have here, we got a 95, a 92, a 90, then a 65, and then another 93. So clearly this seems to be an A student who had one bad day, one bad exam. If we take the mean for this, the mean gives them an average of 87, which is now a B. So this A student now has a mean score of 87. However, if we were to take the median or look at the mode for something like this, those two are not affected by outliers, which is why we look at all 3 of them if we want a clearer picture of what's going on with this student. In this following example, it says a newspaper surveys wages for assembly workers in regional high-tech companies and reports an average of $22 per hour. The workers at one large firm immediately request a pay raise, claiming that they work as hard as employees at the other companies, but their average wage is only $19. The management rejects their request, telling them that they are already overpaid because their average wage is in fact $23. Can both sides be right? So in this case, actually, yes, they both could be right. All of this has to do with the word average that's being thrown around here. The report that came out in this newspaper reports an average of $22 an hour. It does not tell us how that average was calculated. We assume as consumers that average is mean, but it might not be. The word average is used for lots of different calculations in math. So when the workers looked at this, they assumed probably that it was one thing when it may have been something else. So the average wage for this, they're saying they're only making $19. But the management is saying that their average wage is actually $23 because they could be looking at two different ways to calculate an average. Let me give you an example. So let's say that there's 5 workers at the company and their wages are $19, $19, $19, $19, and $39. If you calculate this average using the median, then it is actually $19. And median is a way of finding an average. But if you were to calculate this average by finding the mean, adding these 5 up, and then dividing by 5, you actually do get 23. So the management might be finding the mean, and the workers are finding the median. The reason I would go with the workers, though, is because this $39 that's over here is probably somebody who is making a much higher salary than everybody else. Maybe this is a management position. Maybe this is the boss's son. But it's an outlier, and it's affecting the average of everybody else. It's not really a clear picture of what's actually going on. And in this case, I don't think it's a fair measurement to use the mean when you have an outlier. Okay, what we're going to look at next is something called symmetry. Symmetry has to do with where the mode, the median, and the mean are all located. You will have symmetric distributions if the left looks exactly the same as the right. So basically, it looks like a mirror image. That's when it's symmetric. But if it's not symmetric, it's considered skew. So a distribution could be left skewed if the values are more spread out on the left, meaning where are your outliers? The outliers in this case are the left. The mean would also get pulled to the left then. Median and mode are not affected by outliers, so they would be wherever they are. But the mean would be pulled over to the left because the outliers are on the left. Versus right. Right skewed is where is it more spread out? So where is the outliers in this case? Outliers are on the right, which pulls the mean towards the right. So we're going to look at 3 different situations here, and we're going to decide if we think it would be symmetric, left skewed, or right skewed based on a graph. So the heights of a sample of 100 women, number of books read during the school year by 5th graders, and speeds of cars on a road where the visible patrol car is using radar. Okay, so the first one is the distribution of heights for women. This looks like it's pretty symmetric. There doesn't seem to be any outliers pulling the mean one way or the other. The median looks like it's over here towards the middle. This is the height where most women are going to fall. And it's probably somewhere between 5'6", 5'7", something like that. But then if you look here, for every tall woman you have, you're probably going to have that many shorter women. So they balance each other out, and that makes this data look pretty symmetric. For the number of books read by 5th graders during a school year, it looks to me like this is right skewed. There looks to be some outliers over here that are going to pull the mean towards the right as well. And probably what's happening is you have a few students who don't read that much during the school year. Most of them fall somewhere in here. This is where the median and the mode would be, somewhere in here. These are probably the students who are reading the required number of books. And then it seems like you have a few people here who just read an enormous amount on their own because they love to read. Because this is a very high value over here. So you've got a number of students who are going to be interested in reading. Most of them are going to read what's required. And then you have a few that read well above and beyond what's required. And that's creating a tail on the right side. So this would be right skewed. And then for the drivers who can see a visible patrol car, it looks like this is a little bit left skewed. You've got a few outliers over here on the lower end. And this right here seems to be the peak. This is probably where the median and the mode are. And this is probably the speed limit itself. So let's say the speed limit is 55. This is probably 55. And then there's a few people going 56, 57, 60 maybe. Not anybody doesn't seem to be speeding a ridiculous amount. But then you always get these people who slow down to like 15. If the speed limit is 55, they slow down to like 15 miles per hour when they go past the patrol car. That's what seems to be happening in this scenario. So this is, the tail is over on the left, so that would make it left skewed. Okay, we're going to try the same thing now, just imagining what this could look like. So the ages of patrons who visit an amusement park, that's probably right skewed. Most people who visit an amusement park of all places, I'm thinking someplace like Cedar Point, they're probably going to be, the median age is going to probably be in the teens all the way up to the 30s maybe. You'll have a few younger kids there, but then you'll probably have several outliers of people who are much, much, much older visiting an amusement park, but you won't have many. That's what'll pull them over to the right. For the monthly sales of snow shovels over a 6-month period between July and December at a store in Buffalo, that's probably going to be left skewed because you're not going to have really anybody buying snow shovels early in July, if any. You might have one person who buys a snow shovel because it's on clearance. Everybody else is going to buy them between November and December. So you're going to have one, maybe two outliers over towards the left. Then the majority of people are going to be buying them later in the year. That's going to create a tail towards your left. And then for the annual rainfall amounts in 100 cities selected randomly throughout the U.S., that's probably going to be symmetric. You're going to have the average rainfall is going to be somewhere in the middle, but for every dry city, you're going to have an equal number of really, really high rainfall cities like Seattle. And that's going to offset each other, and that's probably going to make it look very symmetric. Okay, and then the last topic that we're going to talk about in this section is variation. Variation describes how spread out your data values are when you look at the center of the distribution. This is also what the next section is going to be strictly about, measuring. These are the 3 types of variation that we talk about. Low means it's not spread out at all. Moderate is a middle spread, and then high means it's very, very, very spread out. So how would you expect the variation to differ between the times in the Olympic marathon and times in the New York marathon? So my thinking on this would be, for the Olympic marathon, it's going to be very, very low variation because these people's times are going to be down to the second. So the times for the Olympic marathon are going to be really close together. They're not going to be spread out at all. For the New York Marathon, on the other hand, anybody can run in the New York Marathon. So you're going to have all different types of runners. You're going to have people who are just starting out and are very slow, to people who have been training for years and are going to finish very quickly. That's going to spread it out and make that look very high for the variation. And then we're going to do the same 3 examples here. We're going to talk about variation for this. So the ages of patrons who visit an amusement park, as far as variation goes, that's probably going to be pretty varied. You're going to have some young people, you're going to have some older people, and then everybody else in between. For the monthly sales of snow shovels, this is probably going to be low, maybe moderate, but most people are going to be buying these in November and December, and it's all going to be kind of centralized on those 2 months. For the annual rainfall amounts in 100 cities, that's probably going to be very high because, again, you're going to have very dry cities and very wet cities, and everything is going to be spread out all in between all of that. Okay, so that wraps up this section. There is one more video that goes along with this statistics chapter, so please proceed to viewing that last one, and then you'll be able to complete your last homework and your last quiz on my math lab.